Palette Animation, the Basics, Lesson 15, Part D. This, I promise, will be the last on palette automation. I don't think anybody's found this very interesting. Nobody seems to be viewing it. I think I put way too much in it, but I wouldn't be doing this one otherwise. I said I would, and I already had it coded, so we should be able to get through this pretty quick, this part. And I also have palette automation, a basic program, so we'll look at that also. So here's what we've got as far as our sprite this time. We've got a whole series of boxes here. We've got 29 pixels across, well, plus the background here, and 29 pixels high. The outside, this light blue, will be palette register 1. The red one, light yellow will be palette register 2, 3, 4, so on, all the way into this little green guy in here is palette 15. What we're going to do is have some animation. We will start with palette register 1, which is this outside box, and we'll change it to the background color, the register. Therefore, when you change it, it becomes background color and it becomes invisible. And then we'll do palette register 2 to the background color, 3, 4, so on, as we work our way in and do that last one. And at that time, the screen is all background colors, like everything has disappeared. And we'll take a little delay and we'll come back out. We'll start in the center this time. And we'll start with 15, we'll restore it, 14, 13, work our way back out to palette register 1. That's all we're going to do. It just gives you some more examples of doing automation. We're going to take this sprite and we're going to put 48 of them on the screen now. We're going to put 8 of them across each row, and 6 rows gives us our 48, which shows you just a few instructions. We're changing pretty much the whole screen. So let's look at some code. Okay, you've seen this before. You've seen it in part A, B, and C. D is exactly the same stuff. Okay, all the way down to clear screen. There's no change whatsoever above like the previous 3 have been. Then we're going to load up register X with an address at 2304. That's our initial screen value. I think in the other programs we used 3030 where we wanted to place that sprite. Remember, our screen is addressed from 2000 to 7FFF, so 2304 is close to the upper left corner, so that's where we're going to start with our first box. We'll push that on a stack just to reserve a couple of bytes. Now we're going to do a couple of loops of for I equals 1 to 6 and for j equals 1 to 8 type loops. Okay, which we got six rows up and down and 8 across at each row. So we'll load up our 6 and store that on a stack. We'll load up the starting address of this row, which is what we got up here is this 2304. That's the very, very, very beginning corner. And we'll store that to say here's our starting corner for this row and store it for the starting address of the box we're currently working on. They're both the same, upper left-hand corner. Then we'll do 8 columns. We're going to do across. We'll save that. We'll load up our sprite like we did in the last 3 lessons. We'll load up where we want to put it, which is the current address, which we just stored up here. We'll save that address and we're going to go off and display it. We'll have to save it because our display routine will destroy X. So we'll go to the display. Let's look at the display routine real quick, okay? Same exact display routine as we had in lessons A, B, and C. The same thing. No difference. Just keeping it simple. Come back, we'll pull our address of the box we're working on currently, or we just worked on, and we'll bump it by 15. We'll bump to the next starting address of the next box. So we're going to bump over 30 pixels or 15 bytes. And remember, our sprite is 29 pixels wide. And the last half of that second byte is a background color, so we're leaving one space in between there, 1 pixel background color. And we'll store our new current address to work on and we'll deck our counters. Or more display? Yes, there is. So we'll do this loop again until we get all 8 boxes across. When we do that, we'll follow through, and we'll check here. Is there any more rows? Yes. If it's equal to 0, no, we're done. We'll get out of here. If not, we'll load up the beginning box. Okay, box bag. We stored way up here at the beginning of the row we just worked on. We got that very first address, that row, and we will load this, do this LAX 128 times 30 of X. What is 128 times 30? 128, if you recollect in the screen size we're working with, is bumping down one complete line of pixels. Okay, remember there's 256 pixels across, or 128 bytes, so we do come down one row times 30, so we're going down 30 pixels down. Our sprite is 29 pixels, so we're leaving one background color line in there. So we're just bumping down 30 pixels, branch up back up to the top of this loop. Store, here's where the beginning of this row is, and the beginning of that box on that row. Go right through the loop again to go through that 6 times, and we're done. We get down here where it says branch equal to box done is right here. We'll clean up a stack what we pushed on it, and we fall right into the main loop, just like on the last 3 lessons. We'll get a character. So Q is quit, M is for motion, and R is for restore to palette. It's the same code as last time. I didn't take any other stuff out. So if you don't have an M, a Q, or an R, it's going to fall through with that one we did last time, 1 through F. That all still works. It's still in there. That could have been ripped out, but it's still in there. But that's all the same. The only thing different is this motion routine. And that's the only thing we really probably need to talk about. Anyway, we're going to load up our background color in register B. We're going to hit the number of palettes we want to change. We want to change 15 out of 16. We don't want to change our background palette, which is palette 0. We'll keep that 15, and we'll load up palette register, start with palette register number 1, and we'll store that background color in palette register 1. Remember, we're showing you, we'll start at the outside loop. 1, we'll change it to background color, 2 to background color, and each work our way into. So we'll do all 15 of them, 1 through 15. We'll put the background color and blanket everything out on the screen. And you notice in here we got a routine here, branch 7 delay. If you don't delay it, it goes so fast you don't see anything happening. It just, the whole box completely goes away. It's that fast. It just goes away. And when we fall down through here, we're going to go off and do delay 3 more times because it is so fast, this code. You just need a delay in there. You can play with the delay and yourself and see how fast it is and how slow you can make it. So we've got the screen is all background color now, and we'll start now from the center and work our way out. So we'll load up number of palettes to change. Again, is 15. We'll store that, and we'll load X with palette 15 plus 1, and we'll load up the input, our RGB, our palette registers, plus 16. Okay, so we're 1 past our registers, and we're one past our palettes. Why are we 1 past it? Because we're going to do this. Come back. We're going to go backwards through this loop. So we're going to go load B minus Y. Well, I don't know if you've used, my goodness, a beginner's thing. So if you do a minus Y, it does the minus the address in the register prior to doing what you're asking it to do. So in here we got Y plus 16. It will back off 1 and make it plus 15, which is our last color, and load that. Store B into minus X. X is 1 past our register 15. It will back it up to 15 and store it then. Okay, take the delay and keep going. All we're doing is going backwards through these registers. Okay, just for a visual effect, and go through there until we're done. Clean up the stack and back rest the main loop. Okay, that's it. We're kind of done with this here. Just do our main loop and go through, wait for another key, and do whatever you feel like doing. Thing of note, our routine works. All we have to do is change our width and height, and that routine works for any size sprite we have in doing it this way. Remember, this is a simple, quick, and dirty way of doing it. Again, our sprite is 30 pixels wide, 29 of them have something in them, and the last one on each one is a 0, which shows the background color. So when we bump from here plus 15, it will be right here, and we'll have a separation of 1 pixel. Our height is 29 pixels. When we bump down, remember we went to 128 times 30, so we'd have a 1 pixel separation for viewing it. Okay, our palet's the same, and everything else down here is the same, other than you can look at the delay routine. Here's the delay factor. Underscore delay is 16,000. Push X, load that delay, and then just loop through there real quick. So that's the delay. You can change this and test it yourself and see what the different delays do. That's it for the code. Let's see how this thing works. I already have it loaded in, so let's execute it. Bang, it just put off, right there in that split second, it put all 48 boxes on the screen. Now we can do that 1, 2, 3, ABC stuff, and that still works, so we can reset it. Now we can do the M for the motion. That it just all on the screen. M just takes them backwards, takes them all off, and then they come right back on. You can change that delay to where you can see it where it works better, okay? And we can, like I said, we can change a bunch of them and do M with that. It'll restore it back to the original ones. That's it. I will do one other thing to show you the speed of this thing. I'm going to offline over here, which you can't see. I'm going to change the delay to, instead of 16,000, I'm changing it to 2. Yep, just plain old 2. Now I'm going to hit the motion key. Okay, I am hitting it continuously. Every once you'll see a blink, because we're not doing a VSync on here. We're just backing this thing anyway. If I did a VSync, you wouldn't see it. But I am actually hitting the M key as fast as I can hit it, and you don't see anything. Like I say, you're seeing the sync, but you don't see anything else. That is how quick it is. And I'm going to hit quick on that. We're done with the assembly part. Let's look at the basic program I have. Okay, like I say, again, I'm not that great of a basic program. I can get stuff done, but I know you guys do this all the time, can probably speed this up. So what I'm doing here is give itself an array of 16 to store the current palette. So we'll save it. And what we're doing is peeking at FFB0 plus whatever it is. So we're going to get all 16 palettes. Okay, and I've got this and ampersand 3F. Remember from part C, I said we need to strip off the high order 2 bits. Okay, or you don't have to, but you can. I'm just stripping off the 2 bits because when I print this out in hex, what the palette looks like doesn't look right with them 2 high order bits on. So that's all that was doing. And we're saving that into that array. And we're taking a new palette, which is down here. Got the palette 0 is black, and then blue, and all the different colors we're going to use in our palette here. We'll put in the new palette, okay, and print that out also. And we'll do a print next key. When you hit any key, we'll do H screen 2, and then we're going to work with in the graphics text printing. And we're going to change the foreground color. The background color is in here is always 0. We're going to keep it at black because our palette 0 is black. And we'll change it to palette register 1. We'll print it here, and we'll put out the letter C. The next line will go to palette 2. And we will print out the COLOR, COMP, you can see it, it's color computer 3. Okay, and it's just note here, dupe pattern 5. Well, this here comes to it's 16 characters across. We only have 15 palettes to work with because our palette 0 is that. So I just duped. If you look right here at line 250 and 260, they're both using palette 5. So anyway, each one's using a different palette. We'll do that, and we're going to do a double loop here. We're going to do a for I equals 1 to 40. That's the number of iterations we're going to do. We're going to work with palettes 1 through 15. We're going to get a random color we only got 64 colors, so we'll do a random 63. If it comes back as 0, then we'll do it again because we don't want to change, put color 0 because 0 foreground background would be nothing. So we'll poke that into the palette register 0 plus Y, which would be 1 through 15 as it goes to that loop. And when we change all 15 of them, we'll go up and do another iteration and go through that, and we're done. Go sub, which is wait for a key. Then we'll restore our original palettes back to H screen 0, and we're done. And you will be able to, if I go over here, that is also loaded, so we'll just run it. Because both of them's in there at the same time. All right, there it showed you what the original palette was in hex and what the new palette is in hex. I did that during testing so I know what I had. Press any key. Okay, it puts out there as our color computer 3. Each character has its own palette. Okay, and this is what you could do palette animation for. If you remember, if you got all kinds of words and instructions on a screen, now hit the space bar, it's going to randomly go through each palette and change them. They're going to do 40 iterations of it. I'm going to hit space bar now. And you'll see it's going from palette 1 to 15. You can actually see it step across the screen because it's a lot slower than the assembler language. And we're doing 40 iterations of it. Each one of them colors is randomly generating the number. And palette's restored. Now, I already restore because if you don't restore it, you could end up with foreground and background color both being the same exact color just by chance. So I'm going to run that again so you get to see it again. Press that. And there it is again. I'll hit spacebar and there it goes again. So anyway, something you can play with just to show you can do palette automation in BASIC. You just tell you it's much slower, but you can do it. And this is going to be all we have for palette animation. I'm done with it, and I'll come up with something else to do in another lesson, hopefully in the near future. But anyway, that is it, I believe. Yep, that's it. See you soon.